talk about today is how to find the equation for these Ferris wheel problems that I've been talking about. So let me just remind you. Here's the Ferris wheel. It's like a ride you go on into an amusement park. And let's know some facts about it. Let me tell you some facts. So let's sort of say that the diameter of this Ferris wheel is going to be 44 feet. Let's say that also it's 5 feet above the ground. And then additionally, you get on this Ferris wheel at this location. So maybe there's some kind of set of steps over here or a ladder or something to climb up and get on. So this is going to correspond to t equals 0. And it takes 12 minutes for a revolution. Okay, and you can see that we're rotating counterclockwise. The goal here is to find an equation h of t, which represents the height of this Ferris wheel. Okay, so my advice is to draw a picture of what this graph looks like first, and then try and find the equation. So if we draw little axes here, we mark off time, we can kind of see right away. For example, at time t equals 0, this height that we're interested in would be 5 feet plus the radius of the circle, which is 22. So this height is 27. So we know that at t equals 0, we're at a height of 27. So I'll let that be 27 there. That'll be your first point on our graph. Now, since it takes 12 minutes per revolution, the other important times we can find, like I might be interested, hey, how high is this thing at the top? Well, that would correspond to a quarter of the way around the circle. So that means 3 minutes will have elapsed. So that goes with t equals 3. And for the same reason, that's halfway around the circle. That's t equals 6. Here's 3/4, t equals 9. And we're back at the beginning, t equals 12. All right, so the height at 3 minutes would be 5 plus the full radius of the circle, or 49. So now we know the second point on our graph would be, not 5, forgive me, 3 minutes, and a height of 49. So we get this. And then at 6 minutes, we're back at the same height we started at. And then at 9 minutes, we're down at the bottom. Well, down at the bottom there, you can see that right up there. The height is only 5 because we're 5 feet above the ground. That's the height the Ferris wheel is above the ground. And then lastly, at 12 minutes, we're back at the same height we started. So we can see the general shape of this picture. Looks like this. Okay? So that is a sine graph. Just to remind you of the different graphs you can get. That's what sine x looks like. Here's what cosine x looks like. And then you can negate those. And when you negate them, you reflect them in the x-axis. So here's negative sine x. And here's negative cosine x. And depending on where you start on the Ferris wheel, you'll get different equations. You'll get different formulas. All right. So we know then our graph looks like this. Blank sine blank times some number t, the amount of time that's gone by, plus blank. Okay. Well, if we look at this equation has a line running through the middle of it, a midline, if you will. And midlines are always written right here at the end. We can see in this case it's 27. Okay? Then we also know that the number in front is referred to as the amplitude. And the amplitude is the distance above or below a midline that a function like sine or cosine reaches. And that distance in this case is 22. It happens to also be the radius of the Ferris wheel. If you think about it, that makes sense. The highest the Ferris wheel can ever go is its radius above its middle and its radius below its middle. Okay. So, lastly, this number in here is usually called the frequency, denoted with a B in most textbooks and so forth. There's a formula that tells us that period equals 2 pi over b. Now, period is the amount of time it takes for the curve to repeat itself. And if you look at this picture, you can see that we've got one cycle of this sine curve by the time we get to t equals 12 minutes. So we know that the period is 12, and we get 2 pi over b. If we solve that, we're going to get 2 pi over 12, or pi over 6. So this thing here is the equation of our Ferris wheel. If we want, we can graph that and get a look at it. So let's go to y equals. Get rid of the equations that are anything that's in there already. Make sure you're in radian mode when you graph these. Okay? Our equation was 22 sine of pi divided by 6, close parenthesis, plus, let's go back, I think it was 27, actually. Okay, great. So that's it. We're in radian mode. Let's go to window. 0 to 12 is reasonable. It takes 12 minutes to get around this Ferris wheel. And the maximum height we reach is, like I said, around 49. We'll leave the Y max at 70. Let's press graph and take a look at this. Okay, can't really see it. Let's check my mode, make sure my mode is correct. I'm in radian mode. Let's go back to Y equals. Yep, I see my mistake. It's a popular mistake. I forgot to put times X in here. Okay, I've got to put my variables. Second insert, X. Okay, that's better. I'll hit enter. And now we'll graph it, and we'll see a curve looks just like the curve we expected it to look like. Here's the fun part. If you hit trace, you can check certain values. So 6:27, we knew that would happen. 6 minutes into the ride, 22nd. What about 3 minutes into the ride? There it is at that max height of 49. How about 9 minutes into the ride? Sure enough, it's at 5 feet like we expected. And then lastly, at the end of the ride, we're at 27 again. So that's how you find the equation of a Ferris wheel.